When someone hears the phrase edge of the universe, the mind immediately creates an image, a boundary floating in darkness, a wall, a cliff, a place where space simply ends. But the observable universe does not have a physical edge. There is no wall waiting in the distance, no glowing barrier, no cosmic border checkpoint. The observable universe is not the entire universe. It is simply the region of space from which light has had enough time to reach us since the Big Bang. It is not a location. It is a limit imposed by time. Light as the ultimate speed limit. Everything begins with one simple rule of physics. Light has a maximum speed, and nothing can travel faster than it through space. This speed is not just fast, it is absolute. Because the universe is about 13.8 billion years old, one might expect that the observable universe would extend 13.8 billion light-years in every direction. But reality is more complicated. While light was traveling toward us, space itself was expanding. The galaxies that emitted that ancient light are now much farther away than 13.8 billion light-years. Today, the radius of the observable universe is about 46 billion light-years in every direction. That means the full observable universe is roughly 93 billion light-years across, and that is only the part we can see. What the edge actually looks like. If someone could somehow travel outward, galaxy after galaxy, what would they eventually see? They would not encounter a wall. Instead, they would see older and older light. Looking deeper into space is the same as looking back in time. Light from distant galaxies left them billions of years ago. At extreme distances, we see galaxies as they were when the universe was very young. Eventually, galaxies disappear entirely. Beyond a certain distance, the universe becomes so young that stars had not yet formed. There were no galaxies, no planets, no structure as we know it. And then comes something extraordinary. A faint glow filling all of space. This glow is the cosmic microwave background. It is the oldest light we can see. It comes from a time when the universe was only about 380,000 years old. Before that moment, the universe was so hot and dense that light could not travel freely. Space was opaque, like the inside of a star. The cosmic microwave background is not the edge of space, it is the edge of visibility. The expanding horizon. The most unsettling part is that the observable universe is not static. It changes over time. As the universe ages, light from more distant regions has time to reach us. That means the observable universe slowly grows. But there is a twist. Because of accelerated expansion driven by dark energy, some galaxies are receding from us faster than light due to the expansion of space itself. This does not break physics because they are not moving through space faster than light. Space between us is stretching. Those galaxies are already beyond a different boundary known as the cosmic event horizon. Light they emit today will never reach us, not in a billion years, not ever. There are regions of the universe that are permanently cut off from us, even though they exist. Why we can never reach it. Now imagine building the most advanced spacecraft possible. Imagine propulsion systems far beyond chemical rockets. Even if humanity developed near light speed travel, the observable universe would remain unreachable. As a spacecraft travels outward, space continues expanding. In many directions, expansion outpaces the ship. The boundary keeps moving. Trying to reach the edge of the observable universe is like trying to run toward the horizon on Earth. No matter how far someone walks, the horizon remains at the same distance. It is not a physical destination. It is defined by geometry and time. Even worse, in a universe dominated by dark energy, more and more galaxies will eventually slip beyond our observable region. In the far future, observers in the Milky Way may see nothing but their own merged galactic remnant. Distant galaxies will fade away, their light stretched beyond detectability. The universe will appear smaller, even though it is larger than ever. Beyond the observable. The most profound implication is that the observable universe is almost certainly not the whole universe. Most cosmological models suggest that space extends far beyond what we can see. It may even be infinite. If that is true, then everything visible to humanity is only a tiny bubble in a vastly larger reality. There may be galaxies, stars, and perhaps entire civilizations existing forever beyond our observational limit. We will never see them, they will never see us. Not because of distance alone, but because of time and expansion. The speed of light creates a cosmic isolation. The loneliest future. Billions of years from now, expansion will continue accelerating. Galaxies outside our local gravitational group will move permanently beyond visibility. Future astronomers living trillions of years from now may look into the sky and see only darkness beyond their own galaxy. They may conclude that their galaxy is the entire universe. They would be wrong, but they would have no evidence to prove it. The observable universe would shrink to almost nothing from their perspective. Cosmic history would become undetectable. The cosmic microwave background itself will stretch to wavelengths so long that no conceivable detector could measure it. The ultimate proof of the Big Bang will fade away. The true meaning of the edge. The edge of the observable universe is not a place in space. It is a limit in time. It marks the boundary between what has had enough time to influence us and what has not. It is a reminder that knowledge is constrained not only by intelligence or technology, but by the structure of reality itself. There are parts of existence that are permanently beyond reach, not because we are weak, but because physics demands it, and that may be the most humbling realization of all.